Coming up on StarTalk, we're reopening old wounds regarding the status of Pluto. I've got with me in my office Alan Stern, Mr. Pluto himself, and we spend the whole time talking about that little bugger in the outer solar system. Welcome to StarTalk, your place in the universe where science and pop culture collide. StarTalk begins right now. This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. Today we're going to do cosmic queries. And we got Chuck for this, right?
Oh, definitely.
But this is a very special cosmic query.
It is.
Oh, this hits deep.
Yes, it does.
This
is the Montague and Capulets. This is the West Side Story of dwarf planets.
We got with me my friend and colleague, Alan Stern. Alan, welcome back.
Neil, thank you.
Give me some love here. Oh, man. Alan, welcome back to the crib here. We're here at my office at the American Museum of Natural History. And you're one of the world's, I'm not going to say one of, I'm going to say the world's expert on Pluto. Can I say that?
Wow.
You just did.
Yes.
The man, but let's hold Pluto just for a minute. I just want to catch up. I haven't seen him in years.
I got to say, this Pluto thing, though, sometimes I feel like I'm typecast like an actor on Gilligan's Island.
Oh.
It's the only thing people talk about is Pluto.
No, that's not one. We'll get to Pluto because this is a cosmic queries, and so people they can't shake Pluto.
Yeah.
You know that. People can't shake Pluto.
Well, it's everybody's favorite planet.
It's everybody's favorite. So, but let's catch up. What have you been doing? So you're still a vice president at the Southwest Research Institute in San Antonio, part of the space division. Very busy research institute, a lot of different scientific.
A lot of science, a lot of engineering.
Mm-hmm.
The institute was formed back in the 1940s for the public good.
Oh my gosh.
And does a lot of federal research, state and local stuff, but also research consortiums for industry. Everything from oil and gas to
being Texas.
Automobiles. Yeah, but electric vehicles, automated vehicles, just thousands of engineers and scientists.
Cool. So you've been there for since you left NASA.
That's right.
Okay. So you may remember I was at the launch of New Horizons mission back in 2006. And if I remember correctly, that mission to Pluto was the most powerful rocket with the lightest payload ever, just in combination, so that it could accelerate and get the hell out there before you died.
Mission accomplished.
That's the number one rule in any science project.
Yeah. When I was a little kid, I was washing cars and babysitting and doing everything I could think of to buy bigger and bigger model rockets. You have no idea.
The kind you would launch in your backyard.
Yeah. Estes model rockets.
Estes,
right?
Yeah.
Oh, wow. Yeah.
Oh,
right?
Yeah.
Right?
Yeah.
And the biggest one was the Saturn V with like 4 D engines or something.
Right, the D engine.
The D engines was the biggest.
I only got the one where you stomped on a balloon and it shot it off with water.
Yeah.
I couldn't get any further.
That's a starter kit.
That's a starter kit.
Yes, exactly.
That's lame. That's lame.
But then we got the New Horizons, 81-foot tall rocket, 70-foot payload bay, most powerful variant. I got to order every upgrade. I'll take the lightweight nose cone. I would like all 5 solid rocket motors.
Wow.
Everything to make it go as fast as possible.
Right.
And then we built this little spacecraft the size of a desk, very compact. So this thing was built to launch school bus-sized spy satellites and big communication satellites and things like that. And we more or less took an Atlas V, amped it up with every upgrade you could think of, and then launched it basically empty. And of course, you got the highest possible burnout speed. So, Apollo astronauts, 3 days to the moon.
We're now talking about New Horizons, no longer about your kid model rockets, right?
Yeah. He transitioned very quickly that way.
We're in the big boy rockets.
Yeah, that was a blurry transition. I was like, man, you were a really advanced kid.
But think about this. Apollo would launch 25,000 miles an hour, 3 days to the moon.
Nice.
Tom Hanks.
Right. Exactly.
Right? New Horizons, 9 hours.
Right. And didn't you get to the asteroid belt in 3 days or something?
Well, not that quick, but we got to the asteroid belt in record time, faster than any spacecraft.
Yeah.
Just 3 months.
Right.
And Jupiter in a year.
Okay. But this also meant by the time you got to Pluto, you were booking.
Yeah.
Right? So
how do you slow down to even take a picture
they
of
don't.
Pluto?
I mean, in the old days, we got used to flybys.
Right.
And later on, you went into orbit, but this was like the resurrection of the flyby.
Right.
Where you got to get ready for all your data in just a few seconds.
And one shot.
One shot?
Once you're gone, you're not making a U-turn.
You can't come back. Right.
Get it
So
right.
wait a minute, can
or
we
go
leave
home.
It's just one blurry picture and with a sound effect that goes, meow.
You hope the pictures are not
Pretty
blurry.
much it.
So anyway, it was a fond memory being there. And so it took how long to get to Pluto?
It took 9.5 years.
9.5 years.
Because it's a long way.
And so you just in the Bahamas over those 9 years? What
That's
happened?
all I was doing. Yeah. Yeah.
So when you do that,
we were busy. I mean, you had a lot to do.
When you do that, when is the optimum time? When is Pluto closest to us so that you can intersect it?
Right. Well, we actually, the optimum time in order to get there fast is when it's in a certain orbital position, but it's not closest. It's near closest.
Okay.
But what really matters, it's in the plane of the solar system.
Okay.
And we got there right at that exact time. In fact,
What he
set a
left
time.
out there is that Pluto's way the out of the plane of the solar system.
Oh.
that was implicit and
Right.
unstated. So at the point where it crosses the plane of the solar system, you don't want to launch something from here and have to leave the plane of the solar system. That's where all your
It takes a lot
momentum
more
is.
fuel.
Right.
And that slows you down if you have to spin fuel climbing out of the plane.
Yeah,
Okay.
Right.
Yeah. Because you're already in the plane with Earth.
Right.
And you got, all of this adds to your favor.
Right.
Okay, continue. I'm sorry for that interruption.
Where were we? We took a little detour.
Yeah, we took a little detour, but no, it was 9 years.
9 years out. Right.
Yeah, so 9 years. But, like the Voyagers, which went all the way out to Neptune, they had 500 people on that project. Scientists, engineers, flight controllers. By the time we did, the whole way, exactly.
Yeah.
And by the time, we did it with 50 people.
Wow.
And so the 50 of us were doing the work.
You're doing everything.
Yeah.
Doing everything.
Yeah.
Mm-hmm.
And so we were pretty busy.
So then, with our friend of StarTalk, David Grinspoon, he's been on Dr. Funky Spoon. Yeah. Yeah. He's, you banded together with him to write Chasing New Horizons.
Yeah.
And with this long subtitle.
Yeah.
What was that subtitle?
Inside the epic mission to explore the ninth planet.
Did he say ninth planet?
The ninth planet.
We'll get back to that.
Oh boy, here we go.
Neil.
Blood drawn.
It's happening already. Shot across the bow.
Blood drawn.
Oh, here it is.
Blood drawn. No, so that's. I mean, that book was needed because Pluto was a big mystery for so many people for so long.
Well, yeah, and this mission was, so much in the public eye that really needed to be documented.
Yeah,
and of course, David's an amazing writer.
Yeah, we all love David. We love David. So also, since then you've been in space. I hear.
Yeah,
you went above the Kármán line.
Wow,
we
We did that on Virgin Galactic.
Did
Neil's Pluto news upset you that much? You're like, I'll show you. I'll go investigate it myself.
Let me get into
I'll prove
space
it myself. Like, I'm going to space, damn it.
How long was it? Like 4 minutes of weightlessness? About how long is
4
that?
minutes between engine cutoff and reentry.
Yeah.
But a hell of a ride and a tremendous experience to see the planet.
So what science were you doing on it?
Yeah, I was.
So you weren't just joyriding?
Right.
Okay.
As much as I wanted to look out the window, I was sent. I'm going to be doing a NASA mission, which is going to be determining how well the Virgin Galactic spacecraft can be used to do astronomy on these missions, like unmanned sounding rockets. And on this first mission, I did some physiological experiments using myself as the guinea pig, and also some practice for the astronomy mission, kind of get the timing of everything down.
Okay. So you weren't purely a tourist.
Right. In fact,
mean, that's noble, but still sucks. I'd rather just look out the window the whole time.
Right, yeah. Just be there for the ride. You know what I mean?
And you would love it. You should do it.
Yeah, I don't know.
It's a beautiful view.
Yeah, listen,
why not? Why wouldn't you?
Any industry that considers an exploding rocket on the launch pad a success, I'm not.
No, they don't call it success. They call it an experiment rich in data.
That's even worse.
That's what the rocket people call it. No. So what else have you been up to?
Been doing a lot of research as a scientist.
Right, because your expertise is obviously not just Pluto. Your solar system objects of all kinds.
Nice.
Asteroids, comets,
Yeah, working on things all across the solar system, even the moon.
Mm-hmm.
I'm on Europa Clipper that's going to be launching this year to study Europa and the ocean of Europa, the plumes and the potential for biology.
The liquid undersurface.
Yeah. I'm on the Lucy mission, which is an asteroid mission. Just got launched in 2021.
Is Lucy an acronym?
No, Lucy's a pretty name. It was named after Australopithecus Lucy.
Oh, that Lucy.
Lucy.
Which was named after the Beatles.
Because-
Lucy in the Sky with Diamonds. Yes.
Yeah. And it's all about
Everything goes
just
back
like
to the Beatles.
the Australopithecus. It's about the origin of our solar system, just like
Oh,
the origin of
I see.
hominids.
I see what you did there.
That makes
Oh, the Lucy mission. Very cool.
Yeah.
All right.
And what data are you gathering to tell you about the origin of this little solar system?
Well, all these missions contribute to that.
Oh,
Right? It's a big kind of like CSI, right? With hints and clues everywhere, and you have to build a whole story
CSI,
up.
the solar system.
There you go.
And all of a sudden, Alan takes off his glasses. And do.
There you go. So,
Mysteries unsolved.
Yeah.
Right?
the Lucy mission is a good example. The asteroids it's going after co-orbit with Jupiter. Neil won't like this, but they orbit in Jupiter's orbit, and there are tens of thousands of them that Jupiter has not cleared. Nonetheless, planet Jupiter
So these are the
pockets of
Trojan
Trojans
asteroids.
leading and trailing.
Yeah.
Lucy's the first mission to go explore them.
Mhm.
It's thought that these
But just to be clear,
Trojan asteroids.
just to be clear, so these are places in the Jupiter-Sun system
Okay.
where forces of gravity and centrifugal forces balance. So like Lagrangian points.
Okay.
Right. We did a whole
Nice.
thing on Lagrangian points.
Yes,
didn't
we did.
That's a whole
Yeah,
explainer.
which
So
one-
Jupiter has a forward and trailing Lagrangian points, and stuff finds
Just
itself
gets
there.
trapped in it?
It's like it doesn't know where to go because
Yeah.
there's nothing pushing it anywhere.
exactly.
And there they go around the solar system.
It's like the
around
Wizard
sun.
of Oz poppy fields.
What?
You just wander in and you just stay. You know?
Is that what?
Yeah. You just,
It's a little like that.
yeah.
And the objects that are there are thought to be sourced from the same region as a lot of the Kuiper Belt objects.
Okay.
So we're going there so we can compare them to the Kuiper Belt objects that New Horizons
Nice.
has explored.
Nice.
And we see if it's really right, if that
just-
part of the story is
Just
correct.
remind me, the leading ones were Trojans. Did they have a different name for the
So why do you call
trailing
them
ones?
Trojans? I mean, because I'm thinking Trojan horse when I hear Trojan.
Right.
Or
Yeah.
is it?
Right.
So there's got to be some
Right.
origin for why they call it
yeah,
Trojan.
and I'm not a historian.
But didn't they
so-
call the other ones a different name?
No,
Like
they're just a leading and a trailing cloud.
right,
Okay.
but
They're called the Lagrange points 4 and 5.
4 and 5, L4,
Okay.
L5. But I think only one of these packs are called Trojans, and I think the other
No,
pack.
they're both called Trojans.
You think
they
so?
are, I promise
Okay.
you.
All
Yeah.
right.
I think
Yeah.
they have individual names,
got
but they're
people
more
checking.
obscure.
Well, they
I
hiding
got
something.
people.
That's what we know.
They what?
They're Trojans. They're hiding something. We should not trust them, is what I'm saying.
So I'm glad we're finally learning more about these objects because they're just sitting out there waiting to be
Yeah, and they've been begging for exploration and never.
begging.
And
Totally
now the
begging.
Lucy mission is going to go see almost a dozen of them.
Mm-hmm, mm-hmm.
Some of them have satellites, and we'll visit some of those.
Okay.
And that mission got launched in 2021. We just did a first practice asteroid flyby in the main belt. We're going to do another practice asteroid flyby in 2025.
How many people get to say that? Let's practice
Right.
with a whole asteroid.
That's amazing. I got to tell you.
Because we got to get it right on those flybys.
Uh-huh.
And then starting in the late 20s, we'll do a whole series.
Late
of
2020s.
Late 2020s, we'll do a whole series of flybys of Trojans. Then we'll dive back in our orbit down close to the sun and come back out and go to the other Trojan cloud where we'll complete that exploration. If there's an extended mission, we'll do even more.
Wow.
And this will all end in the 2030s. So it's a long-term program of exploration.
So just to be clear, once you've established this orbit around the sun going out to Jupiter,
Right.
it's minimal fuel, right? Because you've already earned this
That's
orbit.
right.
And so now you're just sort of redirecting it a little bit.
Right. So the rocket does the initial boost, and then we do Earth gravity flybys. We've already done one.
Yeah.
We have 2 more to do to
Mhm.
make the whole mission come.
Yeah.
And the principal investigator, Hal Levison, is a part of the team that dreamed up the whole geometry and orbital mechanics of how you get so many flybys into just one mission.
Right. This is the genius of what they got to do. Like with the Cassini mission to Saturn,
Right.
it's orbiting Saturn, but it's visiting moons every time.
Yeah.
And all these loop orbits. Oh, let's check out this other one. You do a little adjustment. I mean, it's brilliant that we can exploit the gravitational fields of other stuff. I mean, it's almost diabolical.
I'm Ali Khan Hemraj, and I support StarTalk on Patreon. This is StarTalk with Neil deGrasse Tyson.
So, Alan.
Neil.
Alan.
Neil. It's a pattern.
Don't get me started. Okay, get me started.
Neil.
We alerted our fan base that you were going to be on. And most of them knew your expertise, but others were fresh in the room for that. And we collected questions.
Yes, we
from
did.
them. And these are Patreon members.
Yes, they
Oh,
are.
excellent. Excellent.
These are the people who keep us afloat.
Let's see what questions.
Yeah, what do you have?
All right, here we go.
I haven't seen them. I don't know anything about them.
Let's go with Sean Ravenfire. Now, I wonder if that's a real name or not. Ravenfire. It sounds like, a video game character. I am Sean Ravenfire. I am here to collect the crystals.
The crystals.
All right.
Not even the money, right?
No,
It's got to be something.
Your money is meaningless. Give me the crystals. Okay. So Sean says, hey, I'm still a little fuzzy on the difference between minor planet, dwarf planet, and planetoid.
Ooh.
Can you please explore the differences?
I'm fuzzy too, actually.
Yeah.
Yeah.
Everybody's fuzzy because the terms are not, some of them like planetoid, no one uses. You hear it very occasionally. No scientist I know uses the term planetoid.
Wait.
I don't even hear.
What do they call Thea? Wasn't that a
Thea.
planetoid?
So
Thea
was
that made the moon.
The term is planetary embryo. That's the term that's really used.
This sounds like a PC thing. You
That's-
got to add syllables and add another word.
But that is the term that's used.
Planetary
It's
embryo that collided with
Earth,
right?
to make the Earth moon system.
I did not know
That'd be
that.
a planetary spermatozoa?
Okay.
Embryo.
Yeah.
I'm sorry, you're talking about never.
But the embryos are basically the building planets, and there were a lot more of them originally than there are now because many of them combined through collisions to make bigger and bigger objects. Thea ended up spalling material into orbit around the Earth, and it collided. It created the moon, but most of Thea ended up in the Earth.
Right.
And this was a big thing. It was the size of Mars.
Yeah.
Right.
Yeah.
Big hit. Right.
So I was just trying to get my vocabulary straight here. So you would call that a planetary embryo, not a planetoid.
Because no one uses that. Really.
Okay.
So now
it's really an archaic.
Okay,
is
so-
that the same as protoplanet? The planetary
embryo and
protoplanet?
Those are
same thing?
interchangeable.
Oh, we're good. So protoplanet. Good.
Protoplanet.
All right. So now, for the longest while, my whole life growing up, we're about the same age. I knew of this thing called the Minor Planet Circular,
Right.
which tracked asteroids, basically.
Right.
So I always thought of asteroids collectively as minor planets.
Yeah.
Is that term still a thing now that we've added vocabulary to the system?
Sometimes it's used, and it's mostly used for the small, kind of potato-shaped, lumpy things in the solar system, not the bigger things.
Okay.
The term dwarf planet, I'm actually very proud of this. I coined the term in 1991 in a research article in the journal Icarus, and it was meant to be
Icarus features solar system-based science.
This is the solar
distinct
system,
from
first
the Astrophysical
the first
Journal.
research journal of solar system science.
Okay.
And Carl Sagan was one of the original editors of it back in the 60s, 70s when planetary science was being born as a field.
Mm-hmm.
And in 1991, I published an article that was about mathematical prediction, that there would be a large number of Pluto-like objects discovered.
Mm-hmm.
And I termed them dwarf planets in analogy to dwarf stars and dwarf galaxies and so forth.
Okay.
And they're meant to be...
Because that word is already in
It's
use.
smaller.
It's already in use.
We already
that
have
makes
it.
sense.
So smaller, much smaller planets, the ones that are the size of continents. And that term's been used very widely.
Okay.
And we see dwarf planets all across the Kuiper Belt, which is part of the revolution of the Kuiper Belt that we didn't know about till the 90s, is that dwarf planets are more populous than the 4 terrestrial planets and the 4 giant planets combined.
Mm-hmm.
And there's one dwarf planet orbiting in the asteroid belt called Ceres,
Ceres.
the largest of
Which
the
was an
asteroids, which
asteroid.
is a mini planet itself.
Okay, so
right?
Okay.
Right?
Gotcha.
Asteroid's kind of a zip code. So, it's like a Kuiper Belt object is kind of meaningless. It's just an object in the Kuiper Belt. It's like a zip code. Technically, New Horizons, the spacecraft, is a Kuiper Belt object. For the time being, it's an object in the Kuiper Belt,
Okay.
right? So that's just a zip code, right?
All right.
But
So
dwarf
now, how do
planet
you
actually means
get
something
up to the term
specific.
Now, I'm not trying to push back here because I'm out of my league between you two, but I want to know, how do you go from being floating rock to planet? Because there's got to be a difference between.
It's a big difference.
Yeah,
There's a big difference.
one of them is how do you make the jump from
Well, let's back up. How do you go from potato to dwarf planet?
yeah.
So the thing about potato-sized objects, so these are things that are the size of counties or mountains. And they're, most of the asteroids that you can look up in a book or that we've flown spacecraft by, they're lumpy and they have irregular shapes. And that's because that's the shape that, as they were assembled, they just came to rest in when the assembly was finished.
Mm-hmm.
And that shape is controlled by the material strength of the object.
Okay.
The thing is, as objects get bigger and bigger, more and more massive, eventually they get massive enough that their self-gravity causes them to form into a sphere. And then we call them planets.
Okay.
Once they're big enough to be a sphere, like Pluto, they're planets. The smallest of them are called the dwarf planets. And then there are larger planets that are Earth or Jupiter size. And
They're all
eventually,
spheres. And those are all spheres.
All spheres.
those are there's a continuum. They're all spherical objects.
So sphere is definitely a determining characteristic.
It's the hallmark.
It's one of them.
It's the
That's
hallmark.
one of them.
If you're on Star Trek and they show up somewhere and turn on the viewfinder,
Everything
you
is
see-
round.
you see a round, rocky something or thing with an atmosphere that's round, you go, oh, they're a planet this week.
All right, let me ask you this, both.
But
All
did
right,
we
so-
get through dwarf planet, a planetoid planet? What?
There's no
minor
planetoid.
planet.
Yeah.
See,
The
so you
minor
said there's
planet.
no
Okay.
minor.
The
I
minor
just want to get
planets-
more questions.
Minor planets are these little rocky guys. They used to
Mhm.
be called, it's an 1800s, 1900s term, minor planet,
Okay.
right?
Mhm.
And that's kind of a legacy term.
All right. So before we move on to the next question, one last
In
question
fact,
for both.
asteroid itself is very legacy.
Right.
Because who was it? Not Herschel, was it?
Somebody around 1800.
Some dude.
Yeah, he's got his telescope and he sees this dot of light. Like stars are just dots of light. They're so far away, they're just dots of light in your
Right.
telescope. They see a dot of light, except it's moving.
Right.
And it's like, so it looks like a star, but it's not a star. So asteroid. Star-like.
Star-like.
Right.
Yeah.
So that's like the
Okay.
biggest misnomer there ever was.
Right.
Right. Yes, visually, but if you would care what the thing is, and we still call them asteroids,
Okay.
star-like from the Greek. Or
Excellent.
It's just
All right.
legacy.
That's legacy. All right. So one last thing, and then we're going to move on because I'm taking up way too much of the Patreon's time. Does composition have anything to do with it? So let's just say that it's round, but it's an aggregate of just larger objects, but they're not condensed. They're not really solid. They're just kind of a congregation.
We haven't seen anything like what you're describing.
Oh,
And
okay.
if you look across the planets of the solar system, whether they're made of ice or rock or they're gas giants or whatever, they're all contiguous bodies, not agglomerations like you're describing,
Right.
right? They're one big spherical thing because the gravity crushes everything into that spherical shape,
Okay.
right? And they might have a core and a mantle and a big atmosphere above it, for example, or they might have a core and a mantle and an ocean layer like Europa,
Right.
and then a layer, an outer
layer of
ice, for
Right.
example, right? But they're all the same. They're essentially spherical objects, and their shape is driven by the force of their own mass that creates self-gravity.
Okay.
You know, another way to say this is if you had three objects that were each themselves massive enough to be their own sphere,
Right.
and you bring them together,
Right.
they're making a sphere. Just
There you go.
That's how
I got you.
That's how the universe.
That's how it rolls.
That's how it rolls.
That's how it rolls.
And the same
We're making
thing-
a sphere no matter what.
But the same thing applies when stars collide. and they can merge into a still bigger star, into a larger sphere.
Right.
Right. And it's the same physics
Okay.
all the way through.
All the way through, no matter where you are in
Yeah.
the universe.
That's the good thing about physics.
There you go.
Mm-hmm.
That's true.
All right, give me some more.
All right.
And make this quicker this time.
All right, here we go. This is Andrew Coffey, who says, "Good day, Dr. Tyson, Lord Nice, Sir Alan. I know very little about Pluto, so I'm super excited to hear you talk. I'm hoping you can enlighten me. I'm wondering if celestial bodies like Pluto are only able to form and exist at the extreme distance from the sun, or could they be orbiting closer, perhaps near a smaller or cooler star? And if so, do we hope finding an exoplanet that is similar, simply too small or too far away from the star to be seen from the distances involved in our observations? Thank you." That's two parts. One, is the distance from the sun.
The main part is could you have them close to the sun?
Right.
In fact, everything we know about the origin of the solar system indicates that Pluto formed at something like half its present distance from the sun. That the solar system is more compact originally, and Pluto and most of the other dwarf planets of the Kuiper Belt were transported outward with also the small bodies of the Kuiper Belt. But Ceres is another example. Now, Ceres is in the asteroid belt. It's a dwarf planet. Some people think it formed there. Others can argue that it may have come from the Kuiper Belt itself. So we don't know, but we know that dwarf planets can exist much closer to the sun.
So just for clarification's sake, because there are people who may not know, the proximity of when you're talking about asteroid belt, Kuiper Belt, the sun, Pluto, so how's it go? Where's it go?
So the sun's in the middle of the solar system, right? It's the big kahuna, right? That controls all the other orbits, right? And then we have the 4 rocky planets, Mercury, Venus, Earth, and Mars.
Right.
And then there's an asteroid belt just beyond the orbit of Mars.
Okay.
It stretches for something like 100 million miles outward.
Jesus.
Okay, it's big.
I did not know that.
And then you got the
It's huge.
4
That's huge.
gas giants.
That's amazing. Who knew that? Go
Then
ahead.
you have Jupiter, Saturn, Uranus, Neptune.
Right.
By now, Neptune's orbit is 30 times as far away from the sun as the Earth's is. Right? And probably 15-ish times as far away as the asteroid belt.
Right.
Okay?
Okay.
And then beyond Neptune's orbit is this second belt or disk-like region called the Kuiper Belt, discovered in the 1990s, but predicted back in the 1940s and 50s. And that's where Pluto orbits and a bunch of other dwarf planets and a bunch of much smaller Kuiper Belt objects that are more like asteroids, but much more icy than the asteroids.
Wow. Okay.
And if I understand correctly, the Kuiper Belt was a negative prediction.
What does that mean? I didn't learn that in school.
Yeah, I think it was a negative prediction. I think Gerard Kuiper published a paper saying that there should be a reservoir of objects. I don't know if he called them comets at the time. A reservoir of objects just beyond the red-blooded planets. And since we don't see any there, then he was making some inference about the early solar system. So he was using the absence of evidence as an evidence for something else. And then we find stuff there, and we name it after him.
Yeah, I think it was actually a little different. My recollection of the literature from back then is that there were really 2 scientists. One was named Kenneth Edgeworth, and the other was Gerard Kuiper. They were both making predictions that beyond the orbit of Neptune, that there was something like an asteroid belt that Pluto orbited in, and that it might contain other planets in it. But it was really beyond the technology of the mid-20th century.
The telescopes couldn't do it, and detectors,
And, you had like Clyde Tombaugh squinting at photographic plates. They didn't have the data analysis
Talking about
tools.
the discoverer of Pluto.
Yeah.
Okay.
So they had big enough telescopes, but they didn't have sensitive enough cameras, and they didn't have computers to do the painstaking data analysis.
This is AJ Stavely, who says, hello, Dr. Tyson, Lord Nice, Dr. Allen, so much respect. I am AJ from Atlanta, Georgia. My question is, what unanswered questions has New Horizons answered or you have discovered about the Kuiper Belt that researchers like yourself didn't already know or you were surprised about? Also, if is Pluto's dance with Charon why it appears to be so geologically active? Thank you so much. So a two-part question, but both very
get
cool.
Through all of that.
Yeah, that's a
so
lot.
We found a lot of discoveries.
Okay.
And you don't have enough time on this show. If I came back 2 or 3
All right,
more
let's
times.
go top three then.
But
Okay,
I want to
top
tell
three.
you,
Top three then.
a good example is that Pluto itself.
Okay.
Right? We wondered for a long time if its surface would be flat or rugged. Basically, because we knew the surface is made of nitrogen ice, and nitrogen ice is structurally weak, it would make a surface that was almost entirely flat.
It's so weak that
but
even Pluto's gravity would just flatten it out.
Yeah, exactly.
Smooth
you
it
got
out.
it. But if the nitrogen is just a frosting on top of a water ice crust, you could have mountain ranges and canyons and craters and all the rugged topography that we actually saw. So we answered that question the first day with the first pictures that came back from New Horizons of Pluto.
Wow.
And then when we went further out into the Kuiper Belt and made the first flyby of a small Kuiper Belt object, we found out how they were born, how they were formed.
This was not an accidental encounter. You're
This was
targeting
intentional.
you're targeting other Kuiper Belt
Exactly.
objects with that trajectory.
And
Cool.
this was a goal of the mission. And 1 billion miles beyond Pluto, we flew by this Kuiper Belt object, Arakoth. No one had ever been to a Kuiper Belt object. And from its shape,
Arakoth.
yeah,
Okay.
it means sky in the Powhatan Indian language.
Okay. Yeah, I knew that.
Yeah,
Of course.
yeah.
Who doesn't know that?
Wait. You went to Pluto and then went another 1 billion miles?
And now
Man.
we're almost twice as far as Pluto now
Damn.
and still exploring.
Okay.
But when we got to Arakoth, from its geology and geophysics, we could determine that one of the major two theories of how planets get their start, how planetesimals, the seeds of planets, form, was wrong, and the other theory was right. And we found that essentially that these little planetesimals, the seeds of planets, form very gently and through a very slow local accretion process
Mm-hmm.
in which they can
Rather than
colliding at high speed.
collisions.
rather than collisions.
Right.
Interesting.
And there were decades in which computer models were warring, and in one fell swoop, New Horizons settled that with the data on Arakoth.
Beautiful.
It showed you pick one out of a bag and look at it up close, and you could tell one theory's right, one theory's wrong.
Beautiful. So it means they just kind of gather.
Yeah, everybody comes together.
just come
They
together.
start off in little pockets, and the
Yeah.
little pockets end up with little material, boulders and hills
cool.
and mountains that collide with one another very gently and just stick due to self-gravity and build up a lumpy thing, not big enough to be a round thing,
Right.
just a lumpy
Just a-
thing.
Right.
And tell us about the Pluto-Charon dance.
Oh, yeah, that was the other question. So the question was whether Pluto's intense geologic activity could be due to that. And it turns out not,
Due to
to that dance.
the gravity.
The
To
gravity.
the mutual gravity of Pluto and its big
Charon.
moon
Mhm.
that are in a very special state called tidal equilibrium. Turns out that because of that equilibrium, all those forces that might heat Pluto or make that geology go are long gone. And
Tidal
so
equilibrium.
Pluto's-
You mean double tidal lock.
Yeah,
Yeah.
that's
Oh.
right.
There
You
we
know-
go.
You
We
liking
know what
that?
that is.
You know,
But that can't be the cause of Pluto's geology. It's got to do something else.
Okay.
all right.
Interesting.
Very good.
All
And
right.
that
Good
might have to
question
do
there,
with the
at
ocean.
AJ.
That we think is inside of Pluto, just
Right.
like Europa.
Just
So the
like
ocean
Europa.
is not rigid,
Rigid.
so it can shake things up.
Right.
Is
Well, it's also, as it freezes, releasing heat,
it? Oh yeah.
called latent heat. You know about
Yeah,
that.
yeah.
And that can power the
With
geology.
Physics 101.
So wait a minute.
What?
Okay, I failed Physics 101. Freezing gives off heat?
It does. It releases heat.
Mm-hmm. All right. Okay. All right. I'm gonna tell you right now. I've been on this earth for a little while now. That's the first time I ever heard somebody say freezing gives off heat. So I'm just gonna call bullshit.
No.
You can try.
No, I got
No,
one for
I'm
you.
joking.
No,
I'm joking.
I got one for
No,
you.
I'm serious.
No, I got one for you.
Go
Are
ahead,
you ready?
go
Are you
ahead.
ready? Are you seated? Okay.
I'm seated.
Let's look at the other side. So you have water on the stove.
Right.
And you're heating it.
Right.
And you As you heat it, the temperature rises, correct? Okay. Then it hits what temperature?
Boiling point,
212.
212.
You keep heating it.
Yes, you do.
Where does the heat go?
Wait a minute.
It does not raise the temperature. Correct.
It turns into steam.
So the heat simply changes it from liquid to gas.
So the molecular change is
itself.
Okay.
Okay, so now you go the other direction.
Crap.
Yeah, so now you go the other direction.
Yes.
Now you're gonna suck energy out of the water. The temperature drops.
Right.
And then there's a point where you're still sucking energy. The temperature doesn't drop.
Oh, man.
And all it does is change state.
Change the molecular state.
Right.
Damn. That's...
Where was he when you took that physics? You might have done better.
Yeah, I might have done a lot better.
You might have.
Had I had Neil.
Yeah, so we call it latent heat. There's terms for it in physics.
Latent heat.
It's really physics 101.
Hi, how y'all doing? I'm latent heat. Hey. Okay. All right.
You personified latent heat.
Yes,
I will never get this out of my
I know, right? You can't do.
Oh, God.
Also, Sharon, just in the traditions of the field, Pluto is Roman, god of the underworld.
Right.
And moons have traditionally been, not in all cases, but in many cases, traditionally named for Greek characters in the life of the Greek counterpart to that Roman god.
Okay.
And that way there's an homage to both cultures.
Both cultures.
Right. So Pluto's counterpart in Greek is what?
What's his face? The underworld.
Hades.
Hades.
Hades. Okay. It's also the place, but it's also the guy.
Yes.
Okay. And the ferry boat driver to take you across the river Styx is named Sharon.
Sharon.
Yes.
Oh, there you
That's
go.
where that came from.
Sharon! Okay, here we go. Greetings, Dr. Tyson and Dr. Allen. I'm Jasmine from the wine country here in Northern California.
Nice.
I'm very curious. What's the big deal about Pluto? Does it even really matter if it's a planet or not? Why all the fuss over this icy rock at the edge of our solar system?
Oh, yeah.
Whoa, look at that. Oh.
Can I venture a guess that it's been with us so deep in our culture that it's hard to shake any adjustments to those?
Well, that's a guess, but as a scientist, the real reason is that Pluto is the archetype. It's the heralding body of this whole new type of planet, the dwarf planets that we've discovered in the outer solar system. They're active. They have moons. They have atmospheres in some cases. And far from being a rock, it's a big spherical thing.
Right.
Right? And that's why we call it a planet. We don't know what else to call it.
There you go. All right.
Planet modified by the word dwarf.
Right.
Like giant planet for Jupiter.
Which I didn't have a problem. Yeah. I mean, that's, in fact, where we agreed, okay? And one of the correspondence I got back when I was pilloried by third graders, because here, people know, I don't have to give the backstory here.
Dear Dr. Tyson, why are you so mean?
Well, what's really sad is not that he's mean. It's just that he's wrong.
Oh, snap. What happened?
Geek fight. No, it's like.
So you failed your freshman physics. He did great at all that. He did all the way up through PhD, but he's failed his planet test.
No, so we have the word paper, right? And we have construction paper, corrugated paper, toilet paper,
right?
A stock paper, right? So there's paper is a very broad category, and then we modify that with whatever is the next word, and then we know exactly what anybody's talking about.
Okay.
So I don't have any problem with that. I've always felt there's been a shortage of vocabulary so in other words, let me hear, I'm sure we agree here. Jupiter and Earth should not be called the same object in orbit around a star.
I disagree.
No, they're
planets.
rounded, but one is huge in gases, and Earth is smaller than storms on Jupiter's weather system. So wouldn't it be cool if we just had a different vocabulary so that when I use the word, you know exactly what I was talking about. Right now, if I just say, I discovered a planet orbiting a star, so is it gaseous? Is it rocky? Is it large? Is it small? And I have to ask 20 questions just to understand what anybody's talking about.
That's the cool part of science. And
that's a weakness of science.
As a planetary scientist, planet is part of the term of what our field is all about, right? And so we know what planets are. They are the things the central objects of our field, and they are the large things that orbit stars. And they range from the smallest large, they know they're large when they become round and gravity dominates. And from the dwarf planets all the way up to the giant planets, that's a continuum of objects we all call planets.
Yeah.
And planetary scientists agree on that. And in the planetary science research literature, there's no debate.
I don't have a problem. I'm a big fan of words. I have 6 dictionaries on my shelf over there from different eras, and I watch words come and go. I'm just saying, if you have to modify the word planet in order to know what someone is talking about, that's a clarion call for another word, a word yet to be invented that captures both of those simultaneously. And so it's a shortcoming of the lexicon. That's all I'm saying. That's all. Don't look at me all blank. You see how he's looking?
Wow.
You see how?
I'm telling you.
Did you see that face?
I'm telling you. By that, for example, we have different kinds of human beings, short ones, tall ones, skinny ones, big ones, right? We have North Americans and Europeans and South Americans, and that doesn't mean we need a new term for human beings. It just means adjectives help in the English language. And there are all kinds of ways to add descriptors to planets, to stars, to galaxies. We do that all through science, right? And we got to get over these small number fears, right? I mean, if we're going to have only 8 planets, Neil, I'm afraid the periodic table's got to stop at beryllium. You know, the periodic table has 100 and umpteen elements in it, right? We're not afraid of a large number of those.
No.
Just like we're not afraid of having 50 states, right? Or countless numbers of stars and asteroids and everything else.
We only have 49 states. Texas is not a state.
Well, by
It's its
nature,
own country. Just ask anybody from there.
I've been to restaurants called Texas is a planet. So we get used to big numbers of planets now that we see them around stars and lots of them in our own solar system.
And doesn't Star Trek have a much more nuanced system and nomenclature for planets?
Yeah, because they classify planets.
Star Trek is fiction. We're talking about facts.
No, but let's imitate fiction.
Okay,
because
Alan,
they have,
I was on your side until that statement right there. How dare you, sir?
Send him away. Factor 1. No, so I'm just saying there's a term, a succinct term that references, is it an oxygen-nitrogen planet?
Right.
There's a gravity. There are ways of folding that into the term so that someone says,
You don't mind Star Trek having lots of kinds of planets.
Yeah,
See?
I'm
fine.
all in.
We got ocean worlds, right?
I'm all in.
And we got volcano worlds, and we got biologically active worlds,
I'm
and
all
sterile
in.
worlds. It's all good.
All in.
There you
Okay.
go. Adjectives rock, don't they?
On it. Dude. Alan, great to have you back on.
Thanks so much, Neil.
Okay.
It's a pleasure.
All
great.
right. Great. Thanks. We're done here. Oh my gosh, but we're really not done, are
No,
we?
we have solved nothing. we must do it again because nothing has been resolved.
All right. So this has been Star Talk, the Pluto Cosmic Queries edition, if I may call it that. We're going to have to get Alan back because we just barely scratched the surface here. Anyhow, thank you, Alan, longtime friend and colleague.
Thanks so much.
Chuck, always good to have you.
Pleasure.
All right. Neil deGrasse Tyson here, your personal astrophysicist. As always, keep looking up.